Hello, my dear students and the rest of the learners. My name is Julius Meme, and I want to welcome you to this topic by the title, Introduction to Computers. In this topic, we are going to learn about definition of a computer, the parts of a computer, the evolution or development of computers, in terms of the history of computers and the generations of computers. We shall also look at the classification of computers, the application areas of computers, the advantages of using computers, disadvantages of using computers, the safety precautions and practices to be observed in a computer laboratory, and finally, we are going to look at some of the hands-on skills that a learner should be able to execute. Let's commence with definition of a computer. As you can see on this screen, I have 3 illustrations or diagrams of computers. We have computer 1, computer 2, and computer 3. So, how would you define a computer? A computer is a programmable electronic device that accepts data and transforms it into information under the control of programs that have been stored in its own memory. A computer is therefore said to be electronic because it utilizes small or tiny electrical signals or currents flowing through its circuits in order to perform its operations. Data is the raw facts and figures that have no meaning attached to them by the user. Examples of data include letters, numbers, pictures, sounds, and symbols. What is data transformation? Data transformation, also called processing, are the varied activities performed in order to convert or change data to become information. And therefore, information is the processed facts and figures that is meaningful and useful to the user. This information can either be output or it's stored in a storage medium for future use. A program is therefore a set of special step-by-step instructions that tell the computer what to do and how to do it. Memory is the storage location for data and instructions that are accessed by the control unit. Having defined a computer and having seen some of the illustrations that I have already shown you, here is an assignment for you, assignment 1. And the assignment is list 3 visible parts of a computer. What are some physical, visible parts of a computer that you have seen or that you know? The solution is 1, system unit, 2, monitor, 3, speakers, 4, mouse, and other peripherals like printers, scanners, projectors, and any other device that is visible that you can see with your naked eyes. So what are the parts of a computer? So by the end of this subtopic, you should be able to, number 1, state the different parts of a computer. Number 2, explain the function of each part of a computer. And number 3, draw a well-labeled diagram of a computer. A computer is made up of a collection of different components that are interconnected together in order to function as a single entity. And therefore, a computer is not just a single part. It's not just a single device. It is a collection of different components. And of course, each of these components can be a device by its own right that are interconnected together in order to function as a single entity. But a computer is basically made up of two main parts. These two key parts are the system unit and the peripherals. A system unit is the case that houses the heart or the brain of the computer, and it is called, or this brain of the computer, which is called Central Processing Unit or CPU, and drives that store, record, and read data. While peripherals are all the other devices that are connected to the system unit through the ports in order to function. The following is therefore a drawing for some of the parts of a computer. And these parts are labeled as A, B, C, D, E, F, G. The question is, what are the names that you can give to those labeled parts? The answer to that question are: A is an interruptible power supply, what we also call UPS. B is monitor. C is system unit. D is keyboard. E, mouse. F, mousepad. And what is G? What is G? G, as you can see, these are multimedia speakers through which you can be able to hear information that is in the form of audio or sound. Now we have two designs or styles of system units. These are the tower style and number two, the flat style. As you can see, ports are the connectors on the system unit through which devices are connected. And therefore, for any peripheral device to function, it must be connected to a port with the use of its cable, which we call the data interface cable. The data interface cables are the cables that carry data and instructions or information to and from the peripheral devices, while the power cables are those cables that are used to supply electricity or source of power to the various parts of the computer. The most common or basic peripheral devices that are found in an ordinary computer include the monitor, the keyboard, mouse, and speakers. Therefore, the key or many parts of a computer would include the monitor, the UPS, keyboard, DVD drive, floppy disk drive, system unit, speakers, mouse, mousepad, amongst others. As you can see, my dear student and my dear learner, is that some of these parts, such as a monitor, is a device on its own. The keyboard is a device. The mouse is a device. But the system unit is also a device, but within the system unit, we have other parts like the DVD drive, the floppy disk drive. The system unit contains all these, and inside it, we have other devices. The speakers are devices by themselves. And therefore, when we say that a computer entails an interconnection of various devices, we are correct. But each of these devices play a specific role or part. So a computer is this complete standard setup of the basic devices that are mandatory to perform various tasks in the accomplishment of a user function or a task. Monitor is also called video display unit or VDU. This is a television-like device, as you have seen, used to display information on its screen, thus enabling the user to see what is going on in the computer. The keyboard. This is an electronic device that resembles a typewriter and is used for entering data and instructions into the computer through typing with the use of its various keys. The mouse is an electronic device that fits comfortably in the user's palm and is moved on a flat surface to control a special pointer, which is displayed on the screen in order to issue an instruction into the computer. The speakers are those devices used for producing information from the system unit in form of sound or voice that is audible to the human ears. Second assignment, now that we have learned about what a computer is, the next question is, who was the first or which was the first computing device? What is the answer, my dear learner or my dear student? The answer is abacus. And we are going to see this in our next subtopic, which is the evolution or development of computers and the history of computers. So by the end of this topic or subtopic, you should be able to, number one, explain how computers have developed. Number two, represent the numbers using abacus. In the history of computing or computers, the journey began with stones and sticks. So initially, before human beings began using machines for computation, data processing was done manually using simple tools like stones and sticks to count and keep records. This was before 1900 and it started in Middle East. From there, we moved on to abacus. So the use of stones and sticks to count became the precursor of a counting instrument, which was invented by the Babylonians. And normally it's associated with Chinese. This device is called abacus. And this was around the year 500 BC. Therefore, abacus was the first computing device or calculating tool used by the Asian merchants to calculate large figures in around 2000 years ago. The following is a diagram of abacus. You can see that it contained beans and sticks or strings tied in the middle. And in order to count or represent the numbers using abacus, every bit on the upper row has a value or had a value of 5, while each bit on the lower row had a value of 1. And from the right-hand side of abacus, the first string contained or represented units 1 to 9 or 0 to 9. Then the next are tens, the next were hundreds, thousands, 10,000s, in that manner towards the left-hand side. And abacus contained a number of parts, which include frame, upper row, crossbar, lower row, wires or strings, as well as beans. In order to represent numbers, as I have already said, those beans away from the crossbar represented zeros. So to represent a certain number, you had to move a bit from the frame to the crossbar at the center of abacus through the wires running across the frame. For example, the following abacus represents a number which is 7,903. Therefore, as I have said, this string that I have highlighted represented units. And therefore, when a bit was moved from this bar towards the center, that's when it represented a number. For example, to represent 3 on this string, the user had to move 3 beans. That is 1, 2, 3. Each bead represents 1, and therefore this is 3. On the upper side, there is nothing, and therefore this is a 0. This is because these beans are away from the crossbar. Then to represent the tens, from this number, you can see that under the tens, it's a 0. And therefore, you don't move any bead from the upper side. Why do you move any bead at the crossbar or at the center of the crossbar? And therefore, if there's no bead at the center of the crossbar, that represents a 0. Then this string represents a hundreds. In this number, 7,903, we have 900. So we have 9 hundreds, 9 hundreds. And therefore, from the upper side, we have to move one bead. And this is the bead. So any bead moved from the upper side to the crossbar represents 5. It represents digit 5. And therefore, this is 5. Then from the lower side, we have to move 4 beans. So 1, 2, 3, 4. And therefore, 5 plus 4 is equals to 9. So 9 is represented. Then under thousands, we have 7 thousands. So 7, that is 5 plus 2. Therefore, we move one bead from the upper side to the crossbar. And this is the bead. So this bead represents 5. Then from the lower side, we move 2 beans. 1, 2. And therefore we have 5 from the upper side plus 2 from the lower side. So 5 plus 2, that is 7. And that's how we represent 7,909. So that's how we represent numbers using abacus. From abacus, we went to logarithms. This was the next significant end to calculations. It was invented by John Napier, who published his log tables in 1611, in 1614, and then developed Napier-Bonese in 1617. Number 4, slide rule. Slide rule was developed by William Outred, and he used the log tables in 1620s to develop the slide rule. Number 5, mechanical calculator. The Frenchman Blaise Pascal invented the first mechanical calculator in 1647 that added numbers entered within those and was meant to help his father, who was a tax collector. Number 6, Leibniz stepped reckoner. A German mathematician, G.W. Leibniz, invented a special stepped gear mechanism device in 1694 that was a more advanced calculator than Pascal's that could multiply, divide, and extract the square roots. After Leibniz's stepped reckoner by Leibniz, we moved to difference engine. This was an automatic mechanical calculating machine that was steam-powered and commanded by a fixed instruction program that was invented by Charles Babbage in the year 1822. Later on, Charles Babbage developed an analytical engine in 1832, which became the forerunner of modern computers. This machine was to be steam-powered and general purpose, fully program controlled, automatic, mechanical, digital computer, and was to have all the parts of the current day computers. However, Charles Babbage died before this machine was made. He is therefore referred to as the father of modern day computers. Then from the knowledge by Charles Babbage of the analytical engine, Mark I computer-like machine was built by Howard Aiken of Howard University in 1939. This computer-like machine weighed 5 tons. It was 16 meters long and became operational in 1943. Since then, there have been rapid advancements in computing, which is referred to as generations of computers. This leads us to the next assignment, which is assignment 3. And the assignment is differentiate between the first and third generation of computers. What do you think was the difference between the first and third generation computers? The answer is the first generation computers were electronically composed of anionic valves or vacuum tubes for circuitry and magnetic drums for memory, which made them to be enormous in physical size. While third generation computers were electronically composed of integrated circuits and used magnetic disks to store information, and thus these computers were smaller compared to the first generation and second generation computers. We are going to see this and the generations of computers. And therefore, by the end of this subtopic, by the name generations of computers, you should be able to describe the 5 generations of computers. A generation is the pace through which computers have developed based mainly on the basic electronic component that was used to build the computer from the time when it was first invented, or the time when the first electronic computer was developed up to date. And therefore, computer generations, or all computers, can be broadly classified into 5 generations, which are first generation to 5th generation. First generation of computers was between 1940 and 1958. They were electronically composed of anionic valves or vacuum tubes for circuitry and magnetic drums for memory. These computers, a single computer, was composed of about 18,000 vacuum tubes. These computers relied on machine language to perform operations and could only solve one problem at a time. This made the computer difficult to program, and it had limited versatility and speed. These computers relied on punch tickers and paper tape for input, and output was displayed on printouts. They were enormous in physical size and contained many kilometers of electric wires. They used a lot of electrical power and generated a lot of heat, which made them to constantly break down. Examples of first generation computers include Harvard Mark I, IBM 700 series, IBM 650, ENIAC, UNIVAC 1, ENIVAC, ABC, Barras 220. The second generation of computers was between the years 1958 to 1964. These computers were electronically composed of tiny, solid-state electronic devices called transistors that were much smaller than the vacuum tubes. A single computer contained about 800 transistors. As a result, computers became smaller, faster, cheaper, more energy efficient, and more reliable than their predecessors in first generation. They relied on punch cards for inputs and printouts for outputs. They relied on symbolic or assembly languages which allowed programmers to specify instructions in once. They were the first computers that stored the instructions in their memory, that is in magnetic core memories instead of magnetic drum. Examples of second generation computers included IBM 1400 and 1600 series, IBM 141 and 7070, IBM 1794, UNIVAC 3, NCR 300 series, NCR 501, Barras B 500 series, CDC 6600, mainframe computers, CDC 1604, UNIVAC 1107, Atlas Leo Mark III, and Honeywell 200. The third generation of computers was between the years 1964 to 1970. They were electronically composed of integrated circuits, abbreviated as IC, which were made by combining several transistors together and used magnetic disks to store information. An integrated circuit is thousands of small transistor circuits etched on a semiconductor that is called a silicon chip. And these silicon chips, examples of how they look like is as illustrated as IC1, IC2, and IC3. Processing speeds and the storage capacities of computers improved and the computers became much smaller, cheaper, more reliable, and more energy efficient. High-level language programs, which used English ones and the base-10 number system, were invented and used to program computers. Input was carried out through keyboards and monitors were used to output information. Operating system was used to interface the users with the computer, which allowed the device to run many different applications at one time with a central program that monitored the memory. Examples of that generation computers included IBM System 3 and System 7, UNIVAC 9000 series, NCR Century series, IBM 360, IBM 370, PDP-2, 8-bit microcomputers, ICL 19000 series, Barras P5500, Barras 6700, DEC PDP-8. And DEC PDP-8, my dear student and my dear learner, was the first commercially available mini computer, and its example is as you can see in this presentation. The fourth generation of computers was between 1970 to 1989. They were electronically composed of large-scale integrated circuits, or LSI, and very large-scale integrated circuits, VLSI. These circuits consisted of compressed tiny circuits and transistors into a smaller space on the silicon chip, forming what we call the brain of the computer, which is also called a microprocessor. That is a processor for personal computers. And an example is Intel Pentium, as you can see. These computers made use of magnetic disks, bubble memories, and optical disks to store information. Computers became very small, even to fit in the palm, with very high processing speeds, cheaper, and much more reliable. Computers were linked to form networks, which led to the development of Internet. An Internet is an international interconnection of computers for communication. Graphical user interface, GUI programs, mouse, and handheld devices were also developed in this generation. Examples of fourth generation computers included IBM System 3090, IBM 308, RISC 6000, Cray 2XMP, Barras B700, Apple II, which was the first microcomputer, 16 and 32-bit microcomputers, IBM 370 and 4300, IBM 3 series, HP 9000, Amdahi 1580, and Honeywell DPS 88. The generation computers were between the year 1989 to date, that is the future. These are characterized by the merging of telecommunications with computer technology through the use of artificial intelligence software, therefore making the computers to have genuine intelligent quotient, have ability to reason logically and with real knowledge of the world. These computers are able to respond to natural language input and are capable of learning and self-organization. Artificial intelligence is the science of developing machines that mimic human behaviors, such as reasoning, learning, hearing, seeing, and communicating. These computers accept spoken word instructions, that is what we call voice recognition, and can now assist doctors, managers to make decisions, and can also offer critical expert service to users instead of relying on human professionals. They have extremely very high processing power and speeds and are very small. Computers in this generation, that is supercomputers, can make use of parallel processing that is performing multiple simultaneous operations using more than one microprocessing chip. The technologies currently used and are under research during this generation include parallel architectures, three-dimensional circuit design, and superconducting materials. These computers also have multimedia capability. Multimedia is the combination of audio, video, text, and images into an interactive computer environment to provide a creative and effective way of producing, storing, and communicating information. An expert system is a software designed to make a computer operate at the level of an expert in a specific narrow area of specialization. Examples of fifth generation computers include IBM Z Series 990 Model D32, NEXT Earth Simulator, California Digital Corporation's Intel Itanium 2 Tiger 4. And with that, we have come to the end of the generations of computers. This leads us to the next assignment, assignment 4, whereby you are required to distinguish between a mainframe and a supercomputer. What do you think is the difference between a mainframe computer and a supercomputer? Good. The answer is a mainframe is a big-sized computer after the supercomputers that offer very fast processing speeds and greater storage capacity than a typical mini and are used for performing complex mathematical calculations, while a supercomputer is the largest, fastest, most expensive, and powerful computer that is designed to process enormous complex scientific applications within a fraction of a second. And we are going to look in depth on these types of computers in our next subtopic, which is classification of computers. So by the end of this subtopic, you should be able to, 1, describe the 4 types of computers that are classified according to their physical size. Number 2, explain the 3 main types of computers classified as microcomputers, or what we also call personal computers. The 3 main ways of classifying computers are according to, number 1, their physical size and the processing power, which we also call system performance. Number 2, their functionality, that is the type of data they can process. And number 3, their purpose, that is the number of tasks they can perform. Classifying computers according to system performance is a method of classifying computers according to how fast and powerful they are in processing and handling various amounts of data within a fraction of a second. The 4 main types of computers classified according to system performance are supercomputers, also called monsters, the mainframe computers, mini computers, also called mid-range computers, and microcomputers, also called personal computers. Let's commence by describing supercomputers. Supercomputers are the largest, fastest, most expensive, and powerful computers that are designed to process enormous complex scientific applications within a fraction of a second. Examples of such applications include scientific simulations, aerodynamic design, petroleum research, scientific research, and space exploration. They are mostly found in developed countries such as United States of America, and the examples of such computers include Cray T3D, NEC 500, Cray T3E 900, California Digital Corporation's Intel Itanium 2 Tiger 4, number 5, NEXT amongst others. Supercomputers examples are as illustrated on the screen. Number 2 are mainframe computers. Mainframe computers are big-sized computers after the supercomputers that offer very fast processing speeds and greater storage capacity than a typical mini and are used for processing complex mathematical calculations. A mainframe computer can be used by thousands of users at the same time through the use of terminals and support a variety of peripherals. They are used in large organizations such as banks, government agencies, insurance companies, and industries where they are used to perform tasks that require a lot of computational power. Here are some demonstrations or illustrations of some of the diagrams representing mainframe computers. Some uses of such computers include bulk data processing, industry consumer statistics, bank transaction processing, and acting as nodes of large national and international networks. Examples of mainframe computers include IBM 4381, ICL-39 series, CDC Cyber series, IBM Z series 990 Model D-32. The third type is mini computers or mid-range computers. This is a small-scale computer that is cheaper alternative to the mainframes and has faster processing speeds and greater storage capacity than a microcomputer. They are generally used in applications that don't require the faster computational speeds or large storage capacities available on mainframes. They are well adopted or used for such applications as accounting, that is, execution of payroll, invoicing, and stock control tasks, word processing, database management, and specific industry applications serving as network servers in medium organizations. Here is an illustration of how mini computers are connected in a network. You can see that a mini computer is able to serve as a server to several other computers. They are used in scientific laboratories, research institutions, engineering plants, small manufacturing plants, research labs, in places where processing automation is required. An example of mini computer is PDP-8. The fourth type is microcomputers, also called personal computers. These are the smallest, lightweight, portable, and most commonly found computers that make use of a microprocessor and are designed to be used by a single person at a time. They are the cheapest and relatively least powerful type of computers. They are called microcomputers because their CPU is called a microprocessor. A microprocessor is a complete central processing unit of a computer placed on a single large-scale integrated circuit chip. They are used in training and learning institutions, small business enterprises, in communication centers, and even by individuals to perform a wide variety of tasks. Some examples of microcomputers include 1. ZX Spectrum, Sinclair, IBM PCs, and other IBM compatibles, Apple II, amongst other personal computers. As a result of the technological advancement of microcomputers, various types have been developed that are smaller and smaller in physical size. Therefore, the three main types of microcomputers in operation today are desktop computers. What are desktop computers? These are microcomputers that are not portable and are designed to be used or placed on top of an office desk or a table, as you can see from this diagram 1 and diagram 2. The laptop computers are microcomputers that are portable like a briefcase and are designed to be used by placing it on your lap. Examples of such computers or types are notebooks, tablet PCs, sub-notebooks, amongst others, and they look like the illustrations that you can see. You can open a laptop and close it. The third type of personal computers is the palm-top computers. These are the smallest microcomputers that are handheld in the palm while being used. Examples are personal digital assistants, calculators, mobile phones, or the cellular phones, as you can see on the screen. This leads us to the fifth assignment, which is explain the three types of computers classified according to purpose. What do you think? are the types of computers classified according to purpose. This we are going to get, or the answers to this question, we are going to get from our next topic or subtopic, which is classification according to purpose and functionality. And therefore, by the end of this subtopic, you are expected to be able to, number one, explain 3 types of computers classified according to purpose. And number 2, be able to describe the 3 types of computers classified according to functionality. Let's commence with the classification according to functionality. Now, this is a method of classifying computers according to the type of data they can process or their operation principle. The 2 types of data that computers process are discrete or digital, which is the data that can be represented as distinct values, that is ones and zeros, which do not have any transitional changes over time. And this data is normally represented as follows. Therefore, with this type of graph, you can be able to tell which type of data. Therefore, this represents what we are calling discrete data, which is either a 0 or a 1, on either the positive or the negative side. The second type of data is the continuous data. Continuous data is data that is also referred to as analog data. This data can be represented as progressively changing values over time. So analog data requires time to change from 0 to 1, and it can be represented as follows. That is a continuous wave or a continuous signal, as you can see. And therefore, this means that this data will change from 0 to 0.1, 0.2, 0.3, 0.4 as you move. And then on the reverse side, then 0.1, 0.2, 0.3 as you move up. And therefore, the wave for continuous data is continuous, or the wave for analog data is continuous. Therefore, the 3 types of computers classified according to the type of data they process are digital computers, analog computers, and hybrid computers. What are digital computers? These are computers that process discrete data only. They are the most commonly used type of computers that can process both numeric and alphanumeric or alphabetic data. They are used in a wide cross-section of the application areas. They work with the use of digital signals. Some application areas of digital computers are scientific, industrial, and most other computer-based data processing applications. The analog computers are those computers that process data which is progressively changing values over time by measuring changes in physical magnitudes. For example, change in pressure, temperature, amongst other. They make use of analog signals. They accept inputs which vary with time and intensity and directly apply them to various devices within the computer, which perform the computing operation. The output from the system is usually in the form of graphs, and output signals can be used directly to control the operation of some other machines or a process. Examples of areas where the analog computers are used include manufacturing process control, like monitoring and regulating furnace temperatures, in weather stations to record and process physical quantities, e.g. wind, cloud, speed, in scientific or engineering experiments, and also they are used in military to control weapons, amongst other areas. Hybrid computers. Now, these are computers that are designed to process both discrete and continuous data. How do we classify computers, therefore, based or according to purpose? This classification is a method of classifying computers according to the variety of jobs or tasks they perform. The four types of computers that are classified according to purpose are, number one, general purpose computers. Now, these are computers that are designed to perform a variety of tasks when loaded with appropriate programs. They are thus flexible, making them to be acceptable to most users because they are applying to a wide range of applications like document processing, accounting, amongst the others. They are the most commonly used computers in use today. Special purpose. These are computers that are designed to perform only a particular operation and usually satisfies only the needs of a particular type of a problem. Instructions that control it are built directly into it during manufacture. Examples of special purpose computers include robots. This is a computerized machine that performs work ordinarily done by human beings. Mobile phones. They are used for communication only. Then we have electronic calculators, which are used to carry out calculations only. An indicated computer are computers that are committed to some processing tasks, though they are capable of a variety of tasks. And therefore, generally, dedicated computers are computers that are bought to be able to perform general purpose activities. So they are general purpose computers, but then the user decides to tailor them to perform or to be used to carry out a specific function, such as word processing. Then we have embedded computers. Now, this is a special purpose computer used inside a device and is usually dedicated to specific functions. It is housed on a single microprocessor board with the programs stored in ROM, and they are commonly used in items such as washing machines, cameras, cars, motors, sewing machines, clocks, and microwaves. And therefore, embedded computers are those computers which you don't buy with the idea of buying a computer in mind. What you buy is a device, but then it happens that within that device, there is a part of that device which is a computer. And therefore, you might not know that you have bought a computer. This leads us to the next assignment, which is, after having learned about the history of computers, the generation of computers, and how you classify them, then which are some of the areas where computers are used? The answer to that question is under this subtopic, which is areas where computers are used. So by the end of this subtopic, you should be able to, number one, identify areas where computers are used. Number two, state 10 advantages of using computers. And you should also be able to state 9 disadvantages of using computers. Let's start with areas where computers are used. Computers are used in supermarkets and retail stores to control the flow of stock and alerting the management when a particular item is running out of stock and need reordering. They are also used in offices to store and retrieve information as well as processing documents. In addition, computers are used in banks to automate cash deposit and withdrawal services, for example, with the use of automated teller machines. The computers are also found in industries, and they are used to monitor and control industrial processes with the use of, for example, the robots. Computers are also found in hospitals, where they are used to keep records, helping diagnosis, and controlling life support machines in intensive care units. In addition, the computers are used in transport to monitor and control vehicle traffic, aircraft navigation, as well as making reservations. They are also used in communication to facilitate and increase the speed with which information is transmitted and received around the world. Similarly, computers are used in law enforcement agencies to help carry out criminal investigations and make that process to be faster and more accurate. In education, Computers are used to facilitate in the teaching and learning process through interaction with special programs, as well as in storing the various information that pertains or relates to the institution of learning. They are also used in homes and recreational avenues for recreational activities and storing information. They are also used in libraries to keep track of records of books and other library materials. The computers are also used in government institutions to store government records, as well as improve the efficiency of work within the civil service. They are also used in research by scientists, engineers, and architects to test, design, redesign, and analyze experimental data. We also use computers in commerce to make excellent electronic presentations and adverts on various business ideas and advertisements of varied products as well as services. So what are the advantages of using computers? Why use computers? Computers have very fast processing speeds. Secondly, they are very accurate while processing data as long as they are fed with correct data and instructions. Similarly, computers are more efficient because they utilize minimum resources to process data as compared to human beings or other machines. Also, the other advantage of computers is that they can process voluminous quantities of work repeatedly without getting tired or getting bored, and at the same speed and accuracy as the first one. They also create job opportunities for the computer literate people and therefore being able to earn their living. The other advantage is that they store large quantities of data in a limited space for future use, and thus they produce a paperless office. They are also used to carry out tasks automatically with minimum human intervention until it's complete once instructions have been given and read. The other advantage is that they can perform a large number of different jobs depending on the instructions fed unto them and the hardware characteristics. They help protect information from being accessed by unauthorized people. That is, computers improve the level of security to data and information. The other advantage is that they help in performing tasks that may be risky to human beings and more so to the human health, like in industries where we have chemicals being manufactured. However, anything that has an advantage, it also has disadvantages. And therefore, some of the disadvantages of using computers include, number one, they cause job displacements and unemployment to the computer illiterates. Similarly, the technology is full of changes and therefore they become outdated very fast. They require the training of staff due to technological changes, and this is a very costly affair. They are also expensive to buy and maintain, and therefore not everybody is able to afford new computers. The computers can also cause various illnesses and fatigue if not used appropriately. They give out wrong results if fed with incorrect data and instructions. That's what we call garbage in, garbage out. Fill the computer with wrong instructions or wrong data, and it will give you wrong output. The other disadvantage is that they cause loss of information and frustration if operated poorly as a result of breakdown, crash, or viruses. They are also delicate if not handled properly because once they break down, they may not be repaired or replaced easily. In addition, in the case of power failure, most computers cannot be used because their main source of power is electricity. This takes us to the next assignment, which is assignment number 7, where you should be able to state 3 factors to consider when setting up a computer laboratory. What are some of the factors you need to consider while setting up a computer laboratory? Let's get the answers to this question through this topic, which is safety precautions and practices in a computer laboratory. And therefore, by the end of this subtopic, you should be able to define a computer laboratory and state the safety precautions and the practices in a computer laboratory. So a computer laboratory is a specially prepared room that is set to facilitate in the installation of computers and provide a safe, conducive environment for teaching and learning of computer studies or ICT. The 4 main factors to consider when preparing a computer room are security of computer programs and other resources, reliability of the source of power, the number of computers to be installed, and the available floor space, the maximum number of users that the laboratory can accommodate. Therefore, the 3 main reasons as to why one has to observe the safety precautions, rules, and practices in the computer laboratory are, number 1, in order to avoid accidental injury to the users. Secondly, is to avoid damage to computers. And thirdly, is to provide a conducive environment for teaching and learning. And therefore, safety precautions and practices in the computer laboratory are those rules and measures that must be followed while performing any activity in the computer laboratory. So what are the safety precautions and practices that we're supposed to observe while in the computer laboratory? In this case, we have what we call the behavior in the computer laboratory. Avoid smoking or exposing computers to dust because smoke and dust contains more abrasive particles that can damage computer components and cause wearing or moving parts. In addition, you should avoid carrying food and beverages to the computer room because food may fall into the moving parts of the computer and damage them, while liquids may spill in the computer parts, causing rusting or electrical faults. Avoid unnecessary movements because you may accidentally knock down peripheral devices and thus cause damage to them, which may make you incur unnecessary losses. Always follow the correct procedure for shutting down and starting a computer in order to avoid loss of data and damage to computer programs. You should not open the metallic covers of computers or peripheral devices without permission, and especially when the computer's power is still on, in order to avoid getting electrical shock and damage to electronic components inside. Report immediately any accidents resulting in damage to equipment to the person in charge of the laboratory, and don't try to repair it because this may lead to complete damage of the equipment. In addition, you should perform only the operations that you are sure of and under supervision, and always ask whenever in doubt in order to ensure that no damage is caused due to lack of proper knowledge. How are you supposed to handle equipments and materials in a computer laboratory? You should always select a workspace that is large enough to hold the computer equipment and any additional items required for your work to avoid damage to them from dropping effects. Handle all the equipment carefully in order to avoid dropping or damaging them because most of them are very delicate. Insert and remove disks from their drives carefully without force and when not being used by the system to avoid damaging your files in the disk. In addition, you should always make sure that you label all your storage media using Manyframes that indicate their contents for easy information retrieval. Always keep storage media away from magnets because they can corrupt the data. When it comes to fire and cabling, a computer room should have a carbon dioxide fire extinguisher that can be used to put out electrical fires because water, powder, and foam extinguishers can cause damage to computer components. All electrical cables and wires should be well insulated and laid away from busy pathways in order to avoid the danger of exposing the user to electrical shock and power interruptions. There should be security alarms put in place at strategic points in order to be used to alert the rest of the school community in case there is a fire outbreak. All cables used in the lab should be those that have been supplied by the manufacturer in order to connect computer components. On the issue of power supply, it's very important to note that as a result of power from the main supply not always being stable as would be required in an operating environment, the computer should be connected through an interruptible power supply or UPS that has power surge and brownout protection capabilities in order to protect the computers from being damaged due to power instabilities. Here are some illustrations of some of these uninterruptible power supply in your laboratory. A surge is large amounts of electricity which exceed the maximum level as a device is capable of holding while brownouts are under voltage. A surge protector is used to protect computer from surges, while a UPS can be used to protect it from brownouts. Always install a standby generator that can automatically come on in case of a power failure so as to enable continuity of work even in the absence of the mains. On burglar proofing, it's always good to remember that your devices should be protected from theft, and therefore burglar proofing is a method of protecting computers from unauthorized access and also from theft. These methods include setting a computer laboratory in a secure location that is not isolated from the normal classrooms, Employing a full-time laboratory supervisor or technician in order to ensure that access to the laboratory is restricted to authorized users only. Always fit strong metallic grills and locks on doors, windows, and the roof so as to ensure that they are not easily broken into by thieves. Always ensure that the doors and windows are always closed when the lab is not in use in order to deter unauthorized access. It is also important to install security alarms at strategic points that are easily accessible so that any break-in attempts can be thwarted. On ventilation, it's important to note that proper ventilation enables the computer to cool in order to avoid damage to electronic parts that can be caused by overheating and prevent humans from suffocation. Proper ventilation in a computer laboratory includes ensuring that the room has enough ventilation points, such as windows, installing a HVAC, that is heating, ventilation, and air conditioning systems, and avoiding overcrowding of either people or machines. Dust and damp control is also a very important aspect to observe when you're talking about safety precautions to your computers. Computers require average humidity below low humidity of less than 50%, which allows static electricity to build up and cause damage to sensitive electronic components, while higher humidity than 70% can cause rusting of the metallic parts of the computer system. Low humidity can be eliminated by placing humidifiers in the lab, while high humidity can be controlled by installing the humidifiers. Dust control should be taken care of by ensuring that the lab is located away from excessive dust, fitting the room with special curtains that reduce entry of dust particles, and always covering the computers using dust covers while not in use. On lighting, a computer room must be well lit to avoid eye strain that eventually leads to headaches, stress, and fatigue. The following are therefore some methods that you can use in order to ensure that there is correct lighting. Number one, the monitor should be positioned such that glare and bright reflections on the display are minimized. This can be done by positioning the computers so that the inside of the display or the side of the display surfaces are against the windows. Number two, special window curtains can be used to control the amount of daylight in the room. Number three, the lab should not be painted with overbright wall paints because they reflect too much light, which can cause eye strain to the computer users. The user should also be able to adjust the brightness of the computer monitor until the eyes feel comfortable, or they can use anti-glare radiation filter screens to avoid the eye strain. Avoid using flickering monitors because this can cause extreme eye strain that can damage your eyesight. In addition, when working at the computer for long periods of time, your eyes may become irritated and fatigued, and it is therefore important that you take frequent breaks so that you can rest your eyes. How is the layout of computer laboratory supposed to be? The computer laboratory layout should be such that the instructor can teach from the front and be able to see each student's screen properly, and learner be able to see him without straining. There should be enough room between about the room. There should also be a central printer where students can print their work from for effective management of the printing resources. Share resources that are available, and if possible, the instructor's computer should be connected to a whiteboard. On the side of furniture and the pusher, the table on which the computer is placed must be strong and wide enough in order to bear the weight and accommodate all peripheral devices. The seat for the user must be comfortable and have a straight backrest that allows someone to sit upright in order to avoid muscle pains and back aches that are caused by poor sitting posture. The seat should be high enough relative to the table in order to enable comfortable use of hands on the keyboard, and the eyes must be at the same level as the top of the screen when the user is seated upright. Our next assignment is describe two types of booting. So what are the two types of booting? The answer to this question is under the subtopic on hands-on skills in booting, whereby by the end of this subtopic, you should be able to define booting, explain the types of booting, and be able to outline the procedure of booting a computer. Booting is the process of starting or restarting a computer in which the bootstrap program obtains the operating system from a storage medium and load it into memory, therefore preparing the computer to be ready for use. During the booting process, the computer goes through a process of self-test and preparation for use, which is called POST. POST stands for Power on Self-Test. It is the process in which the basic input-output system, which we call BIOS program, checks all computer components in order to determine whether they are available for use and functioning properly and alert the user in case anything is missing. During this process, the monitor displays information showing the status of each device. Logging on is the process by which a person identifies himself by providing a username and a password. A password is a secret word given to the user before it allows him to use it so as to deter unauthorized users from using the computer. Therefore, the two types of booting are cold booting and warm booting. What is cold booting? Cold booting is the process of starting a computer which is originally off by switching it on through pressing its power button from the system unit. The following is therefore the procedure for cold booting. Turn on the switch at the source of the power supply, that is from the wall socket. Then, if you have UPS, turn it on if it's connected to the power supply by pressing its power button. From there, turn on the monitor by pressing its power button. Then proceed and switch on the system unit by pressing its power button. And finally, wait until the booting process is over by displaying the desktop or requesting you to log on. On the side of warm booting is the process of restarting a computer which is already on in case a certain problem has occurred, which needs to be automatically rectified by the operating system program. Therefore, you can do warm booting through any of the following ways. Number one is pressing the restart button on the system unit. Secondly, you can press three keys in combination, which we call a three-key salute, which is Alt, Control, and L on the delete key. Number three is clicking on the start button. That is if the computer is able to respond to commands. So you should be able to click on start button on the screen. Then select shut down or turn off command from the main list. Then select restart command from the prompt that appears and then click OK command if it is available, or you just press enter key on the keyboard. So any of these three methods can be used based on the one which is functional. Once you are through with your computer, it's always important that you shut it down properly. So shutting down a computer is the correct procedure of turning off a computer after a session of operations so as to avoid loss of data or damage to programs and the computer components. It is done as follows. Always remember to first of all save all your work. Secondly, close all the programs that may be currently running, including those which you might have been using. And then remove any storage media from the device drives. From there, click on Start button on the screen. Then select Shut Down or Turn Off command from the main list. Select Shut Down command or Turn Off in the prompt that appears. And then click OK or press Enter key on the keyboard and wait for the computer to shut down. And then finally switch off the monitor, followed by the UPS and the socket. So what are some of the various keys that can be found on the keyboard? In this next presentation or next subtopic, we are going to see these various types of keys that you can use under the use of keyboard and mouse subtopic, from where you are supposed to be able to describe keyboard layout, type something in Word using the keyboard, and manipulate text using the mouse. And therefore, if this is your first time to learn about computers, just have a computer with you and then start Microsoft Word from it so that you can be able to carry out this task. So the keyboard, which is a keying device, and we are going to learn more about these devices and the input devices video, which is already posted in the YouTube channel by the name MLSwap ICT. It contains various keys. These keys include alphanumeric keys, functional keys, cursor movement keys, and ending keys. special PC operation keys, and numeric keypad keys, as you can see from this diagram. The alphanumeric keys is the largest set of keys that performs the center action of the keyboard, which is mostly used for typing and is composed of numbers, special symbols, and alphabetic letters. And some of these keys include caps lock. When you press caps lock on the keyboard, it will switch between the uppercase or capital letters and the lowercase letters or small letters when typing. Then we have the enter key, which is also called return key, which when pressed, it moves the cursor to the next line or to execute a command that has been selected on the screen. The tab key is used to move text cursor at set intervals of the same line. The spacebar key is a key which is pressed to create a space between ones during typing, while backspace is used to delete characters from the right to the left on the same line. The other set of keys in a keyboard is the functional keys, symbols, above the number keys, and are labeled F1 to F12 and are used to perform special tasks depending on the program in use. The third category of keys is cursor movement and editing keys. The cursor movement keys are those used to move the cursor on the screen towards various directions or sections of a document, while the editing keys are those used to delete or insert characters in a document. Examples of cursor movement keys include the arrow or directional keys. These are the 4 keys that have an arrow marked on them showing the direction of cursor movement when any of the keys is pressed. The page up or page up and page down, paging down keys are used to move the cursor up and down one page at a time, respectively, in case a document has more than one page. The home and end keys are used to move the cursor to the beginning and to the end of the current line, respectively. Examples of editing keys are the insert or ins key, which helps the user to insert or replace the character at the position where the cursor is. The delete or del key deletes characters or character one at a time at the cursor position from left to right and deletes a selected text all at once. The fourth category of keyboard keys is the special PC operation keys. The PC stands for personal computer. These are the keys which are used in combination with other keys in order to give special instructions to the computer. This means they must be pressed together or in combination. They include the shift key, which is usually used in situations whereby the user wants to type a symbol or a character marked on the upper part of a key button that already has another number, character, or letter marked on it. It's pressed first, followed by the key that has the character that you want to type, and then release both the keys. The control key, abbreviated as CTRL, is the key which controls various functions in combination with other keys. The Alt or alternative key is used by many programs written for IBM, that is International Business Machines personal computers, to issue commands or make typing easier. The ESC or escape key is used to quit doing some task or stop activities or signal the program to be alert for special commands to flow. TRTSC or print SCRN or SYRRQ. When shift key is pressed together with this key, it causes whatever is on the screen to be dumped onto the printer, and all what is displayed on the screen except the window elements and the menus is copied and can be pasted as a single object in a document. Therefore, when the print screen key is pressed together with the CTRL or control key, everything that appears on the screen is anchored into the printer until you press that combination of keys again and is also copied and can be pasted on a document as a single object. The 3 keystroke combinations that can help you during times of trouble include Control and Unlock. This causes data scrolling past it to pause until another key is pressed. What about when you press Control key together with Screen Lock key? This causes a program to stop execution completely. And then we have Control, Alt, and Del key pressed in combination. This combination causes a system to stop execution completely and restart like turning power on. The 5th category of keys that are found in a keyboard are called the numeric keyboard keypad keys. This is the set of keys found on the rightmost part of the keyboard used to feed mathematical data, as they have numbers in compact form, just as the keys on a calculator. The numbers on this pad can only be used when unlock key is turned on. This section also has the common arithmetic operators, such as plus, minus, multiplication, and deviation signs or symbols. Whenever you are doing typing using the keyboard, the following are the 4 main typing rules that you must observe while using the keyboard. These are: 1. Always sit upright with both body feet firmly on the ground, maintaining an alert posture. Number 2, place the material to be typed on your left in a position you can read without strain. Number 3, rest both hands on the keyboard with the fingers resting on the home L. They are usually found at the center or the center roll on the keyboard. And always press the key nearest to the home keys with the closest finger. Number 4, always start typing the text, making sure you are using all the fingers as necessary and while your eyes remain focused on the screen and not on the keyboard. Now, the name of the technology that has been used in the construction of the keystroke for a keyboard is called PBNO, that is push button normally open switch type. Other than the use of the keyboard, you also require the use of mouse. In order to use a mouse, you should always place it on a flat surface. Then hold it gently with the middle finger resting on the right button while the index finger rests on the left button. Then slide the mouse on the surface until its pointer points on the item to be selected on the screen. When the pointer rests on the item, manipulate it by pressing a mouse button. The 6 main uses of a mouse are therefore: 1. Pointing on the item. 2. Selecting an item. 3. Opening an item. 4. Starting a program. 5. Displaying a list of commands. 6. Dragging and dropping an item. The following are some terminologies that are used with a mouse. 1 is clicking. When you hear click, what comes to your mind? Now, this is pressing and releasing the left mouse button once, e.g. to select an item or move a cursor to that position. Number 2, we have the term double clicking. This is pressing the left mouse button twice in quick succession, that is faster. For example, when you want to start an application or a program or open a file from the desktop or from a storage medium. Number 3, right clicking. This is pressing the right hand side button once in order to display a shortcut menu or what we call context-sensitive menu. A context-sensitive menu is a list of commands that is normally displayed when you right-click an item. Pointing. This is to move the mouse until its pointer, that is the cursor, rests on the item of choice. And then drag and drop means to press and hold down left mouse button after the pointer is on the item of choice, and then you move that item to the new location and finally release the button. Lastly, it's good to do some exercises or practices using your keyboard and mouse, and you apply some of the terminologies we have learned and the techniques we have mentioned. Therefore, the following paragraph is important, and you are required to type it using a program such as Microsoft Word if it is available. And the passage is keyboard practice, and you are required to type it exactly as it is, and the content is as it is on the screen. It is our trainer's name is MJM, also called MLSwap. He runs 2 YouTube channels called number 1, MLSwap ICT dash for computer stroke ICT content. Number 2, MLSwap Enterprises International for life skills and motivational content. Then we have another paragraph which states, we have learned that the keyboard has 5 main parts, which are dash or hyphen alphanumeric keys. And then we have the symbols there, e.g. ABC and those other characters. Then we have the line for functional keys, e.g. F1, F2, F12, cursor movement and editing keys, e.g. PG up, special PC operation keys, e.g. Alt, Control, numeric keypad keys, e.g. 1, 2, 3, plus, multiplication sign, and the rest. You are required to type the text as it is. And with that, we have come to the end of this topic. Congratulations for choosing to acquire computer and ICT knowledge and skills from us through our YouTube channel by the name MLSwap ICT. You can search for more computer or ICT topics from MLSwap YouTube channel. In addition, you can search for life skills and motivational topics from our other YouTube channel by the name MLSwap Enterprises International. Kindly click on subscribe button and hit the notification bell in both of the YouTube channels for current updates from both channels. For additional correspondence, you can always write it to us through our email, which is mlswap@gmail.com. Thank you very much for learning with us, and God bless you as you continue pursuing your knowledge in our various or through our various topics as posted in MLSwap ICT YouTube channel. Thanks and be blessed.